Previously, I made a video regarding the interactions between atomic particles. To recap, all particles have a different charge, which determines its interaction with other particles. The interactions are summarized by this table. R, G, B, and S represent the different types of particles. A zero on the table means that there is no interaction between two particles, and an A means that there is an attractive force between the particles. Unfilled cells are unknown, and there are 4 cells with an asterisk, where there is some information about the interactions but not enough to know any of them. There are some things that I would like to add to that video. The first is that I assume that the interactions are symmetric. If a particle A calls the force on another particle B, then that particle B is also applying a force with the same magnitude and order but opposite direction on particle A. I also would like to say that the saps are particles separate from shells, and there is a strong attractive force between saps and shells, but it is weaker than the force between a sap and a blue particle. This is necessary for the saps to be removed when a particle is removed from the nucleus. I also didn't mention the order of the forces between particles. It's possible that all the forces between the particles are forces of order 2, just like in the real world, but it could be different or even change based on the particles considered. The magnitude of the force also depends on the distance between the particles, so particles that are far away have a less intense force than if they were close together. The force could be inversely proportional to distance to some power that could change based on the pair of particles. I would also like to add a repulsive force between two blue particles to the table for reasons I will explain later. With that out of the way, we can talk about bonding between atoms. If you have two atoms in the same area, the saps of one atom will attract the blue particles of the other and vice versa. If all the saps have blue particles, there will be repelling forces between the two atoms, and there will be a small or null net force. But if at least one of the saps is unfilled, there will be an attractive net force between them, so the atoms will get closer and, at the end, the previously unfilled sap will be filled with a blue particle from the other atom, and now the two atoms are bonded together, and a lot of energy is needed to separate them. Bonding allows atoms to form more complex structures made out of multiple atoms, and the number of unfilled saps of each atom is the main thing that determines the properties of these structures. There are 3 different types of bonds that depend on the number of blue particles shared. On single bonds, the shell of one atom touches the shell of the other atom, and a blue particle is shared at the intersection of the two shells. On double bonds, the shells of the two atoms intersect at 2 points, and 2 blue particles are shared, one at each point. And on polybonds, the shells can share any number of blue particles. Atoms with 2 unfilled saps and 2 blue particles can bond together and form a structure with 4 atoms, but they can also form repeating lattices with a large number of atoms. I will call these structures with a defined number of atoms, molecules, and repeating lattices, crystals. The rotation of the shells and the position of electrons and saps in the shell are influenced by other interactions that aren't between a shared blue particle and the two saps that are sharing it. If the atoms have enough energy, these bonds can break and new bonds can be formed, creating new structures. just like chemical reactions in the real world. In summary, chemistry exists in the BFDI, although it is different from the real world, and it will probably be useful to explain a lot of things, but this theory still has to be explored further. This is all I have for this video. Goodbye.